Right, hi everyone. Welcome to our lesson 3 of this crude oil kind of section, hydrocarbons, and the idea about what we're doing with it. Today we're going to be looking at the combustion of hydrocarbons, so burning hydrocarbons. We're going to look particularly focus on complete combustion, and we're going to be using word and symbol equations for complete combustion. You need to be able to do that for a number of different alkanes and hydrocarbon fuels in order to be able to do that. And we're going to look at some of our gas tests. We're going to do that straight away, see if you remember those, and then apply that to actually how we can test for the products of combustion to prove that what we say is producing combustion is actually made. So first task, and you can pause your video at this point in a second. I want you in your books or on a piece of paper to identify the lab tests for me, or the gas tests for me, for oxygen, carbon dioxide and water. Okay, thanks a lot. Pause your video there. Right, so over on the right hand side, this image is actually really useful because it summarizes all of the tests that we need to know. Now, I only asked for 3 of these, so we will just focus on those 3 first of all. So test for oxygen, we can see down here representing an image. We will have a boiling tube or a test tube full of our gas. What we're going to do is we're going to light a splint, blow it out so that it's glowing, and we're going to insert it into the tube. If oxygen is present, then it will relight that glowing splint. Second test is test for carbon dioxide. So this one hopefully you should remember, as you've done it a number of times in lessons. So here we put lime water into our sample of gas, and that lime water will start off colourless, and that if carbon dioxide is present, the lime water will go from being colourless to cloudy or milky. You get this kind of cloudy, milky precipitate solution that is created. The third one, the test for water. So test for water, we use cobalt chloride paper, which we can see represented down here. And cobalt chloride paper starts off blue, but in the presence of water, it will turn pink. So they're 3 tests that you need to know, and just very quickly running through the other 2. So test for chlorine. If you have litmus paper, so blue litmus paper, and you put it into chlorine gas, then it will bleach the paper, so the paper will end up white. And of course the classic test for hydrogen. So our sample of gas in a test tube, we've put in a lit splint, and you should hear that classic squeaky pop sound. Now we need to know all of those. So if you haven't, it might be useful to make sure that you've got those gas tests written down and represented somewhere. So today we're moving on to look at combustion. So starting with our definition of combustion, combustion of a hydrocarbon fuel, so remember a fuel containing just carbon and hydrogen, will release the energy that is found within that molecule. So what we're talking about is that the energy is going to be found in those carbon-carbon and carbon-hydrogen covalent bonds, and so when we are burning it, we are going to release the energy. And so over here we can see an example. We've got a Bunsen burner, which is going to be burning one of those LPG gases, one of our fractions from fractional distillation, and we see that release of energy being represented as this blue flame, which is burning, which is a release of energy in the form, well, we get light and we get sound, obviously, and of course there's lots of heat energy that's coming out as well. Now this is also an example of complete combustion, because we've got the air hole at the bottom open, so the fuel is burning really cleanly. There's plenty of oxygen present, and so we're going to get the best release of energy possible. So when we're talking about the chemical reaction that combustion is, the carbon and hydrogen in the fuel are going to be oxidized. So remember, oil rig, so oxidation is loss of electrons, reduction is gain of electrons, so we're going to be talking about the carbon and the hydrogen are going to be losing electrons in this process. Now, as I've mentioned, there are two forms of combustion. So complete combustion, as we can see represented here, when we've got plenty of oxygen present, and so we get the most energy released, and we don't get the production of any dangerous gases like carbon monoxide. And incomplete combustion, which when we close the air hole, we know that the flame goes yellow. That's a safety flame. It's a lot cooler. That's why it's safe, but it's also a lot sootier because we're getting carbon being produced. We're going to get small amounts of carbon monoxide being produced, which because the fuel isn't being burnt completely. And that's what incomplete combustion is. You don't need to know a huge amount about it, so that's going to be the end of the mention of it really for this presentation. So complete combustion is always going to produce two products, and they are going to be carbon dioxide and water. So our general word equation would be our hydrocarbon fuel will react with the oxygen in the air, and the carbon in that fuel is going to combine with the oxygen in order to produce carbon dioxide, and the hydrogen within that fuel is going to react with the oxygen and combine to produce water. And there's going to be the release of energy going along with that as well. So we are going to look at an example of combustion now of a specific alkane. So this one is the first one in the series. It's methane. You hopefully should remember that methane means that it's got one carbon. So the methane is going to combust in oxygen. So it's going to react with the oxygen in the air in this combustion reaction, and it will end up producing carbon dioxide and water. Now, what I would like you to do is to pause the video at this point and write the word equation for this reaction, please. Right, so your word equation should look like this. We have methane and oxygen, which are reactants. They go on the left-hand side, and we've got carbon dioxide and water, so they're our products, so they should go on the right-hand side. Next job is I'd like you to have a go at writing the balanced symbol equation for this reaction. Now I'm going to give you a clue with this one. So methane is of course CH4 formula wise. So use that in order to start off your symbol equation, please. So pause the video now. Right, so symbols wise, you should have methane as being CH4 plus O2, which is of course oxygen, plus CO2, which is our carbon dioxide, plus H2O, which is our water. Now we want to balance this equation, so we're going to start with a carbon. We have one carbon here, and we've got one carbon here, so that is balanced. So we only need one CO2 in order to balance out the carbon dioxide, the carbon in this methane over here. Now we've got four hydrogens here. Now we've only got two in a water molecule. So what that means then is that we need two water molecules. So 2 times 2, 4 hydrogens in order to balance out the 4 hydrogens that we've got here. So 2 water molecules to balance the 4 hydrogens that we've got here. Oxygen wise, so we've got 2 oxygens in our CO2. We've got 1 per water, but we've got 2 waters, so there's another 2 oxygens here. So 2 plus 2 is 4. So over here we've got 2 at the moment. So how many O2s do we need in order to give us 4 oxygens? We of course need 2. So that balances out our methane equation. Right, next one. We're going to work through a couple more examples now. So I want you to pause the videos as we work through these and write out the word and symbol equations for the complete combustions of these different alkanes. So next one is propane. So propane, remember, we need to use the general formula for an alkane, CnH2n plus 2. So propane has 3 carbons. So you should be able to work out the formula for that. It's of course C3H8. So 3 doubled is 6 plus 2 gives us 8 hydrogens. So now can you write out the word and balance symbol equations for the complete combustion of that, please? Pause the video now. So word equation should be propane plus oxygen goes to form carbon dioxide and water. Symbol equation, C3H8 plus O2 goes to form CO2 and H2O. Balance wise, so we've got 3 carbons here, we've got 1 per CO2, so we need 3 CO2s. We've got 8 hydrogens here, we've got 2 per water, so that means we need 4 waters to give us 8 hydrogens overall. 3 times 2 is 6, so we've got 6 oxygen here, plus 4 times 1 oxygen here, so 6 plus 4 oxygens on this side, which of course gives us 10. We've only got 2 here, so we need 5 oxygen molecules in order to balance that out. So complete combustion of pentane next. So pentane, of course, shares a root with pentagon, so that means it's got 5 carbons. So pause the video, work out the formula for pentane. Remember, CnH2n plus 2. So 5 times 2 is 10, plus 2 is 12, so C5H12. So word and balance symbol equation for combustion of pentane now, please. Pause the video. So pentane plus oxygen goes to form carbon dioxide and water. Symbol equation wise, C5H12 plus O2 goes to form CO2 and H2O. We've got 5 carbons here. We've got 1 carbon per CO2, so that means we need 5 of the carbon dioxide molecules. Water-wise, well, we've got 12 hydrogens over here. We've got 2 per water, so what do we need to times by 2 to get to 12? That would, of course, be 6, so we need 6 water molecules. So 5 times by 2 gives us 10. 6 times by 1 gives us 6. So 10 plus 6 is 16 oxygens. So over here we've got 2. So what do we need to times by 2 to get to 16? That would, of course, be 8. Right, these ones are a little bit more difficult. The first one you need to really think about. So take your time, see if you can come up with a solution problem. You can just apply exactly the same process as we've done this time. Don't worry about the answer that you get out, or there's another neat answer. There's 2 possible solutions to this one. But first off, ethane, 2 carbons, so work out the formula. So 2 times by 2 is 4, plus 2 is 6, so C2H6. So now have a go at the equations. So ethane plus oxygen goes to form carbon dioxide and water. So 2 carbons here, so we need 2 CO2 molecules. We've got 6 hydrogens here, so that means we're going to need 3 water molecules. 3 times 2 gives us 6. So 2 times 2 is 4 oxygens, plus 3 gives us 7. So what do we times by 2 to get to 7? It would, of course, be 3.5. Now, that's not necessarily that neat, so there is another solution, which is where you can just double everything. So 2 C2H6 plus 7 O2 goes to form 4 O2 and 6 H2O. This first one is completely acceptable, so you can use half an O2. Remember that moving forwards. So butane next. So butane has 4 carbons, so work out the formula. So 4 times 2 is, of course, 8, plus 2 equals 10, so 10 hydrogens, C4H10. So word and balance symbol equation. Pause the video. Butane plus oxygen goes to form carbon dioxide and water. Symbol equation, C4H10. So we've got 4 carbons here, so we need a 4 in front of the CO2. We've got 10 hydrogens here, so something times by 2 to get to 10, which would, of course, be 5. So 4 times 2 is 8, plus 5 oxygens means that we've got 13. So what times by 2 gives us 13? That would, of course, be 6.5. Or we can double everything, which means we get 2 C2H6 plus 13O2 goes to form 8CO2 and 10H2O. Right. This is an experiment which we could have carried out in the lab, and so this is how we would test to show you that the products of combustion are carbon dioxide and water. So here is our Bunsen burner, which is going to be burning our LPG fraction, and so going to be producing carbon dioxide and water. Now they're both going to be in gaseous state, so they're going to travel into this tubing. Now we could replace this Bunsen with a candle or with anything else that we wanted to burn, as long as it was a hydrocarbon fuel if we were looking to prove this. So hot carbon dioxide gas and hot water gas are travelling down here. They reach this U-shaped tube, which is in an ice bath. That cools down the air, and it cools it down so much that the water condenses. So the water is going to condense down here. We're going to get liquid water formed, and there's blue cobalt chloride paper here. So as the water forms, what's going to happen to the cobalt chloride paper? That's right, it's of course going to turn from blue to pink, proving that water vapour is being produced because we've condensed it here. Now carbon dioxide gas, it's not cold enough for it to turn back into a liquid, so that's going to carry on travelling through here. It's going to bubble out through this lime water in this tube, and of course the lime water in the presence of carbon dioxide will do what? It will turn from colourless to cloudy. Colourless is really, really important here, and that's going to show us that carbon dioxide is produced. It's going to go cloudy because a precipitate, a solid that doesn't dissolve in the water in that solution, is produced, which gives us this white milky kind of appearance. All of this is pulled through because we're going to have a pump which is going to suck air through, well, suck the products of this reaction all the way through this apparatus. Right, questions then. So answer these questions and then pause the video. So what is combustion? It's when a fuel is burnt to release energy. What three things does combustion release? Two of those should be pretty easy. One you might have forgotten, which is the whole purpose of it, of course. So two of them would, of course, be carbon dioxide and water, but the whole purpose of it is to get the energy release. But it's easy to forget that one. Final one, what happens to the carbon and hydrogen in combustion? Of course, they are oxidized. So question 4, how can we test for the products of combustion? State what observations there will be, so what you're going to see when you carry out these tests. So pause the video, answer that question. So we're going to test for carbon dioxide using lime water. We'll bubble the gas through it, or we'll put sample of lime water into the gas. If lime water changes from colourless to cloudy, then we know that carbon dioxide is present. The water will be tested for using cobalt chloride paper, and that paper will change from blue to pink when water is present. Now also attached to the Show My Homework sheet there is a task. There is a worksheet which is about data and doing some analysis that's tied into it. It's quite a difficult sheet, there's a lot of maths on it, so I would like you to have a go at that sheet, mark it using the answers that I've attached to Show My Homework, and then I'd like to take some pictures of your work there and then post that to Show My Homework so that I can see that work, please. Right, hope that has been useful, and I will be arranging a live lesson in the near future for us, so keep an eye out for that one. Thanks a lot, have a good remainder of your day, and I will see you soon.